Hello students, welcome to my class on acceleration, displacement, and average velocity time graph. You have to take note that on a graph there are two axes, which we have the y-axis and the s-axis. Particularly this graph, it is noted that the y-axis carries the velocity, which is measured in meter per seconds, and the x-axis carries the time, which is measured in seconds. A straight diagonal line going up from left to right represents a constant acceleration. And take note that the steeper the line, the greater the acceleration. The horizontal line represents a constant velocity, and a straight diagonal line which goes from left to right represents the deceleration or negative acceleration. If the object has the same decrease in velocity over a short time, like this, the deceleration will be greater. Now look at a graph showing the velocity ranging from 0 to 3 meters per second and a time interval of 0 to 10 seconds. I come again. Look at a graph showing the velocity ranging from 0 to 3 meters per second and a time interval between 0 to 10 seconds. We note that during the first 2 seconds, we observe a constant acceleration, which can be calculated using the formula A is equal to V minus U all over T, where U is the initial velocity, V is the final velocity, and T is the time taken for the velocity. So, when we consider the first section, where we have a velocity of 2 meters per second and a time of 2 seconds, our acceleration becomes 1 meters per second for the first 2 seconds. In the next section, we'll have a constant velocity of 2 meters per second, while the time taken is 4 seconds, which is from 2 seconds to 6 seconds. When we substitute these values into the equation, we will get 2 minus 2 over 4, which gives us a total of 0 meters per second square. In the third section, which is a constant deceleration, the initial velocity uses 2 meters per second, while the final velocity is 0 meters per second. The time taken is 3 seconds, which is from 6 to 9 seconds. When we substitute these values into the formula, we'll get a value which is 0 minus 2 all over 3, which gives us a negative 0.67 meters per second square, or 0.67 meters per second square deceleration. So therefore, to get the displacement of a velocity time graph, we need to first find the area under the graph. You have to take note that this will comprise 3 sections, which we have 2 triangles and a rectangle. For the triangle, the formula to calculate that gives us half base times height. So the area of a triangle for the first part will get a substitution of 0.5 times 2 times 2. For the second part, which is the rectangle, it is base times height. The base we have 2 to 6 seconds, and the height we have 2 meters. Then for the third part, we'd have another triangle which gives us half base times height. You convert the half to 0.5 and you substitute into the values, you get 0.5 times 3 times 2. By summation, when you add these three values together, you arrive at a total answer of 13 meters for a displacement. Next, we shall be looking at a calculation on average velocity, which has a formula which is velocity is equal to displacement over time, where we recall that we had a displacement of 13 meters. When you substitute with a total time of 9 seconds, we'll arrive at an average velocity of 1.44 meters per second. Take note that this is what the object requires to travel an equal distance in the same amount of time. To find the displacement of a graph which has a straight or a slight change, as you see in the graph, it will now be divided into 4 sections. There we have 2 triangles and 2 rectangles. In the first case, we said we already seen the previous displacement, how to calculate it, the various sections. It's just the last part. You now consider the triangle, triangle which is from 2 to 1, and that will be calculated with 0.5 times 3 times 1. Then you add it to the rectangle 3 times 1, which gives you a total answer of 14.5 meters. 14.5 meters. Just before we conclude this lesson, you have to take note that for solving of the velocity time graph, you have to be careful while reading questions on displacement, as sometimes you might be given questions to calculate the displacement of an incomplete graph. In that case, you would have to look for the triangle, the rectangle, a little triangle at the curve, and a rectangle. With this, I round up today's class. I say do